Cool.
All right.
Cool.
Sweet.
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 So I'll get it started. I'll introduce us, Demetrius, and then we'll kind of get started. Does that sound good?
Awesome.
All right, guys. Well, welcome everyone. We want to welcome you guys to another coffee session. I am David Aponte, one of the hosts, and we have Demetrius. And
What's
we have
happening?
we have a very special guest today. We're going to introduce him in a second, but before we get into that, let me just preface kind of some of the things we're going to talk about today. So we have Luigi, who runs ML in production. We're going to talk about what that is, how he got started doing that. But we're also going to take some community questions. The MLOps community asked us to ask a bunch of questions. So that's going to be the format today. We're going to basically do like a Q&A and then just chop it up through some of those questions. Demetrius, would you like to add anything to that?
Yeah. So I will just say this. I have pinched myself a few times and it looks like I am not dreaming. This is actually happening. We have Mr. ML in production himself with us. And I feel so honored to be able to talk to him. We were just literally talking about how he feels like he is not a thought leader in this space. He just has a lot of information because he's already done it and it can be helpful for others. And so I really appreciate the way that you look at things, Luigi. It's obvious that you're a super humble dude. And I'm excited to talk to you about all of these questions that we have.
Yeah, thanks so much for having me today. I'm excited to answer some of these questions. I'm humbled and flattered. I don't think I deserve this much praise this early in the morning here in San Diego, but it's not a bad way to start my day.
Awesome. Well, let me introduce you, Luigi. So Luigi Patruno, I'm sorry if I'm mispronouncing that. I love the way that you've introduced yourself. A man whose goal is to help data scientists, ML engineers, and AI product managers build and operate machine learning systems in productions. That's what we're all about here. That's what we care about. We're very passionate about putting ML into production, about using it to create value. So yeah, we're very happy to have you here. Can you just tell us a little bit about yourself and what you do, Luigi?
Yeah, sure. So I do a lot of different things, but I guess why I'm here today is to talk about what I do for work and for some fun. I'm the director of data science at a company called 2U. 2U is an educational technology company, and what I do there is lead out the team of data scientists, and we work closely with ML engineers and AI product managers to build out operational products that the company relies on that are powered by machine learning and data science. But on the side or at night, I guess what I've become known for is running the blog ML in Production that I started about 2 years ago. And that project was started mainly because I found that there was a severe shortage of information online on what it took to actually build products that people used that were powered by machine learning and not just build classifiers or regressors on their laptops, similar to a lot of online tutorials that you found. So I've been running that blog for about 2 years now. I do a lot of writing there. I've gained a little bit of a fellowship and had some fun posts be shared across the internet. Outside of that, I do a lot of different things: surf, Muay Thai, MMA.
Nice. You also have a newsletter that goes along with that. And I know there's many people that are in our community and subscribe to your newsletter. If you aren't subscribed to his newsletter already, I highly recommend
you should
getting on it.
Yeah, the blog actually started, ML in Production actually just started as a newsletter. And that's the one piece that has been sort of steady and current throughout the entire time I've been running the blog. So started as a newsletter, started writing the blog, started doing a lot of other guest posts and whatnot. But the newsletter has remained consistent throughout the past 2 years now.
It's been incredibly helpful too for myself because I've read it actually a bunch of times. I'm subscribed to it myself, and we know a few other people. But I really love one of the reasons why your newsletter stands out compared to others is, and I think we've talked about this before in the past, Demetrius. But there's a lot of like hello world toy examples, but you really try to get to like the applied ML. Something that's actually going to be used by end users, right? And I would love to talk about what got you started with focusing on that area versus, because there's a lot of things you could have talked about, algorithms, there's like so many things that are going on in this space. Why did you care so much about the applied aspect of that?
Yeah, sure. So, I was building these systems in production, and I had had a couple of jobs as a, I kind of worked across the stack. I started out as a data engineer. So there I was working on building out ETLs and building out data validation tools. Then I got into an ML engineering position at this pretty interesting company called Control Labs, doing, really applied machine learning on high throughput sensor data. And then I moved over to 2U, where I was working on more like, human generated sort of less sensor data and more like business type data as a data scientist modeling that data. And then across all of these experiences, I had touched on very important data issues. And what I found was that when building out systems that had some data science, had some learning component or some component that was based on information calculated from data, the algorithms took up almost no time of my work, right? Uh, of course, some of those positions weren't modeling focused, but as a data scientist, my position was modeling focused. And even there, the amount of time I spent thinking about which algorithm I should use paled in comparison to the amount of time I spent thinking about data structures or how to query the data or how to set up pipelines that would transform data and move it from one place to another, or post that, how to actually deploy the thing so that other people can use it, or and then how to monitor the thing, because we're running a business and if something fails, this can mean lots of money goes down the drain. So, looking at how I was working and then comparing that to what the internet was talking about, which was mostly algorithms or beginners content, I found that there was this drastic misalignment, right? When I needed to
Definitely.
learn about how to do a particular thing, if I went online and just, did a cursory glance through the top posts on, popular blog sites or popular newsletters, I found that it was very rare that I actually got information that was helpful to me. So I found that most people were highly optimizing and really overly focused on a 5% part of the problem. And almost nobody was talking about the 95% of the problem. So that's what sort of motivated me to talk about that 95%, because that's what I spent most of my time doing and thinking about, and nobody else was really talking about that.
Man, that's awesome. That's exactly my experience. I spent most of my time having to do all the boring stuff, the operations stuff, but that's a big part of it. The modeling is such a small component of that process. So another thing that you'd like to talk about, with this applied ML aspect is best practices, things that actually worked well for you, right?
Right.
Could we talk a little bit about some of those best practices at a high level, not necessarily those best practices, but how you started actually coming up with them? Because I think for me at least, it's a bit difficult because there's so many things, everything's changing. How do you develop best practices in a fast moving, industry?
Sure. I think, I'm very much a believer in, uh, you know, do the simplest thing, figure out why that thing is not the right thing to do, and then improve on that. So I don't claim to have all the answers from the get-go, but I've seen things fail. And I'm also a big fan of just researching and thinking through who would know the answers to these questions. So, for example, with productionizing machine learning, there's a lot of startups today or young companies that are just getting started in machine learning. But there's also a couple of companies that have been doing it now for a couple of decades, right? And the companies I think about are Microsoft and Google. And the industries I think about are basically ad tech, right? So if you look at ad tech, the entire reason why it's generated the revenue that ad tech has generated is because they've gotten very good at harvesting data and building systems around that data capture and building models on top of that captured data. So I think a lot of people, have qualms with ad tech because of, what the field does, try to target people to sell them stuff. And that's fine and all. But I try to sort of remove myself from that sort of frame of mind and to just think about the systems that they've had to build to actually, accomplish these goals. And I don't think there's really much of a better place. I don't think there's a better place you can look at to find out best practices for building these systems. So for, even today, what I like to do is to just find as many papers as I can from the companies that have built these systems, because they've already gone through so many iterations to perfect their systems to be able to serve models at scale. The challenge is that many of these companies don't publish a lot about these systems because they're the main money makers at companies like Google, for instance. Another way of finding these best practices is that these companies have had to build internal systems to accomplish their goals. And some of these companies are also cloud service providers like AWS and Google. So they've had to bake in some of these best practices into these systems that they've then sold as services. So I like to study these systems and sort of learn from the decisions made in building these systems and apply them to the systems that I build. So for example, SageMaker is one of these systems. I put out this course on SageMaker, and a large part of the reason why I put out that course is because I spent just a bunch of time studying how SageMaker works, because I wanted to learn more about, what kinds of lessons can I take from that system and apply them to the things that my team is building.
So there's so many good points involved in what you just said. I mean, for one, it's how and where you're learning from. You're studying these different tools. And I'm wondering, as you study them, do you feel like, because each tool is opinionated about something, right? And it has its way of doing it. And so do you feel like there are better ways to do certain things, or is it just like, okay, well, if you want to do it this style, then you have to fit into this mold?
Yeah, I think there's definitely I think there's a lot of subjectivity in data science and engineering in general. I think a lot of people might disagree with me there, but for all the talk about how sort of technical the field is, it's very subjective. And by subjective, I mean you need to think about what your goals are at a high level, and then based on what there's your goals, and then there's also the context. Like your company also already has some sort of data infrastructure, and your goal is to achieve some goals, but within the context of the engineering infrastructure that your company already has. So you may be constrained by, my company's on AWS, I have to use AWS, right? There's not going to be any chance that I can use a GCP tool, because that's just going to violate sort of the axioms of my company's technology organization. So I think it's important to like think about what the goals are, think about what your constraints are, and then to think through, again, how do I get to shipping something as quickly and responsibly as possible? And there's a lot of constraints there that I think can really guide you into figuring out, do I want to do this or do I want to do that?
Yeah, and it's so interesting. Like you talked about reading these papers that come from these big companies that are basically putting things out there for the rest of us and saying, hey, here's how we're seeing the space right now. And David and I just got done with an epic 4-part coffee session where we analyzed the Google paper on continuous training. And I will say that for me was super informative, just to look at how are they seeing this? How do they think about these different problems? And now I feel like I understand so much more, because you get to see beyond your veil, right? Like if you're just working with one thing every day and the same problem sets and the same like constraints, then it's really hard to break outside of that. But when you read a paper from Google who has a completely different vision, I think it gives you a much better perspective on how others are looking at the problem.
Yeah, absolutely. I mean, one of the reasons I started the newsletter was because I was reading many articles and blog posts just on my own, because I need to solve these problems and I need to, learn from other people who had solved these problems. And then at one point, and I was sharing a lot of these articles I was reading with people that I worked with. So I would, almost constantly be sending them links. And then one day I was like, why am I just sending people? Why is my topology just one to many, with me just sending people sort of things one by one? Why don't I just set up an email? Yeah. Why don't I just set up like a blast email list and just send them to everybody? I'm already reading these things. And in fact, if I devote myself to sending out this newsletter, I can't sort of not read these things, because then I'll embarrass myself on a given week by not sending out the 5 the 5 articles. So, the newsletter was really born out of something I was already doing, which was reading as many resources as I could to learn how to solve these problems and to learn from the experiences of engineers and data scientists at these companies that were, really tackling these problems at scale.
I just want to say I really appreciate how entrepreneurial you are. I know that you talked about in the article why you started MLM production, that you had a little itch there, but it really shows. You know, you're looking at like the space. What can be better? You know, what can there's a need there. How can I solve that need? And I love how you do it from a place of where you're already at. Like I'm already doing this. How can I apply that? How can I generalize that? And I feel like that's a really good place to start when you're in this sort of space, trying to do your own thing. Is what are you already doing, and how can you leverage that in
Right.
some way, right? If you're doing a lot of MLF stuff at work, then maybe, you know, if you're reading all this content, summarize that to help yourself learn it, but also that could be useful for other people. So I like how natural, you know, this process has been for you, and it really I think it goes to show that you definitely have a very entrepreneurial spirit.
Yeah, I appreciate that. You know, I don't want to take too much credit. I think it's easier to craft a narrative looking backwards. There's definitely,
Yeah.
you know, there were definitely a lot of, you know, challenging decisions made during the process. But yeah, I sought out to leverage what I was, you know, a little bit of what I was already doing. And I think that's actually a good lesson for, I think, a lot of people out there. There's some people reach out to me and ask, oh, you know, how do you keep up with putting out the newsletter, or writing on the blog, or, you know, how do I get started in something like this? And I think the best advice is always to just take whatever you're doing and add just one more thing. And then just do that for a while. And then after a while, that one more thing becomes a part of what you do. And then you can add one more thing to that. And then eventually that snowballs. So I was reading these articles. So my one more thing was send out these articles to people and maybe add like a paragraph of writing. And that was really hard for a while because I had to develop the discipline to do that consistently. But then after a while, that became sort of like, I didn't have to think about it anymore. And then I was like, oh, let me put out a blog post. And then that was really challenging for a while. And then just snowballed from there.
The power of habit, and
Yep.
I love that. You've said a lot of great things that I wish we could kind of dive into, but for the sake of time and definitely to get to what our community wants, we have some questions for you.
Sure.
We've kind of started with the first one, which is, where do you learn from, some favorite resources? Now you mentioned, you know, Google, you know, looking at some of these production products like, you know, SageMaker, and just thinking through like, all right, what can I learn from this, and how can I apply it to my day to day? Are there any other resources that are some favorites? I don't know who asked this, but definitely, yeah. Anything else that we could add there?
Yeah. So I would say I'm fairly self-taught in a lot of these things. And, you know, I listen to a lot of talks, I read a lot of papers, but beyond just the passive activity of doing that, I really try to, when possible, sort of construct the systems, at least just in my head, that I'm reading about, and to think through just overall architecture, like how would this be possible? So I remember starting to do this with reading blog posts from Uber. Uber has a lot of blog posts on machine learning and data science. And I remember reading, you know, their Michelangelo post. And the Michelangelo post, I think I focused a little bit less on the system and more on the application use case, which was estimated time to delivery for their Uber Eats service. And, you know, they talked about a couple of features that they have in these models. And I remember just thinking through, oh, okay, well, you know, some of these features are going to come from just like historical data sets. Some of these features can be generated from sort of data that's in the incoming request directly from the user. So that's available right away. So some of this data is sort of historical. It needs to be sort of, you know, in the data, comes from the data warehouse. So how do we build services to sort of, you know, make these features available at runtime for a model? Some of them are already available at runtime. What kind of engineering decisions would I have to make in order to make that possible? How would we monitor that system once it was deployed? You know, what kind of feedback would we want to collect? Do we want to collect the exact sort of time at which the food was delivered? Because then we have some signal to be able to sort of reverse engineer what the actuals were and then compare them and see, okay, when was the model performing well? Was it not performing well? So beyond, you know, reading these blog posts, but then thinking through, you know, how would I build the system myself? You don't actually have to build a system yourself, right? I mean, it took Uber like hundreds of engineers many years to build their system, but just being able to sort of fill in the gaps as much as possible and thinking through where you really have no idea how they did certain things. And maybe then, you know, going out and reading some blog posts, looking for some books specifically on those areas. I pride myself more on being much more of a generalist than a specialist, right? I think I get I have a little OCD or something where once I get too specialized, I just start losing focus completely, and I have to change topics. So I tend to think a little bit about the modeling aspect, tend to think a little bit about the data engineering aspect, and I think that's how I do a lot of my learning, is just to think through what's already out there and how I would sort of build out myself.
Yeah. And your learning process is very similar to mine. It's like you just go on these tangents, right? You see, all right, I don't really understand that. All right, let me look something up about that. Let me figure that out. Or I like that. And I think what you just said, even going back about just the activity of like actually trying to construct some of these systems or think through how some of these things are done. That's very useful. It's like I think especially if you're thinking about production level systems, they're often very complicated, a lot of moving parts, and typically it's going to be running in like a distributed environment. So it's worthwhile thinking through something that big. I think it definitely makes a difference in your day to day too, especially if you're, yeah. Anyways, but yeah, that's a really good one. Demetrius, how about you take the next one?
Yeah, I got one here from another community member. And this one, I think there's two ways that I interpreted this question. So the question is, are there any companies in your mind that are doing MLOps in a like very, very excellent way? And I looked at it. I also kind of wanted to tag on a piece, which is how I first understood this. And it was like, okay, so you have companies like maybe there's a bank that's doing MLOps like really well, right? And you've heard about them or you've seen some of the stuff that they put out and you go, wow, or maybe it's Uber, like you were just talking about. You're like, wow, they're doing stuff really well. But then I'm also wondering, are there any like tools that you've seen, like you mentioned SageMaker earlier? Are there any tools that you're looking at and it's like, wow, this is pushing the envelope for MLOps. This is doing it in a really nice way.
Sure. So I think to answer your sort of first interpretation of the question, I'd say, again, companies like Google, Amazon, Netflix, Stitch Fix, the companies, and these are companies that are more, they've had to solve the MLOps piece was just a one part of solving their real problem. For Google, their real problem was, serving ads. For Microsoft's sort of similar for their Bing search system. For Stitch Fix, it was personalizing clothing recommendations. For Netflix, it was personalizing their video recommendations. So these companies were really just trying to solve what I would say are like vertical problems within their verticals, or Amazon, recommending anything. And in so doing and having to solve these problems for people at scale, they naturally came across the problems that sort of MLOps has developed to solve, right? So the way I tend to think of it is they were really driven by solving a particular problem. And at some point, in order to solve this problem, that meant developing the tools and methodologies of what we're referring to as MLOps. So those companies had to develop those solutions. So I think that's the sort of the best companies that you can look at whenever, you can absorb whatever those companies try to put out about how they've solved those problems. And I think, again, you're not going to find sort of better resources to learn these things because the solutions have been motivated by real challenges that the companies have faced. Whereas if you're, one person thinking about just ML ops as a sort of buzzword, you may not be that well situated to identify what the actual bottlenecks and challenges are. So I think learning from these companies is efficient because they've had to solve the problems that they've actually had rather than problems that they think they might have.
Are there any curveballs in there that you're like, ooh, they're actually doing it and you wouldn't expect them to be doing something?
Yeah, that's a good question. It might be a little hard for me to think of a company off the top of my head right now, but I know that I've read plenty. Oh, I was reading. There were really some really great blog posts from Dropbox on solving their problems, and I was really surprised by this. Not because I didn't think of Dropbox as I knew Dropbox was a great technology company, but I didn't really think about them as a machine learning company. And then I read a bunch of blog posts from them that were really beautifully written because I like how they organized the content starting from what their product problem was, and then diving into how they sort of first solved the problem in a sort of really with simple heuristics or with simple statistics. And then they iterated on their solutions and built more complexity into their systems.
Yeah.
And they, they really touched the entire sort of spectrum of what it takes to build a machine learning product. So I think Dropbox is a great example of something that stands out to me that I wouldn't have thought of as an ML company, but they've been doing, at least they've been publishing and claiming that they're doing some great ML work.
I like that you preface that with claiming that they're doing it.
Yeah, I mean, I think there's often large discrepancies between like the marketing collateral and what's actually happening, and I don't think that's sort of malignant. I just think that's just how it happens at times.
Mm-hmm. So what about that second part? Are there any tools that you're like, ooh, this is doing something right?
Yeah, the tools question is one that often comes up, and I try not to be too opinionated with tools, at least when I'm like talking publicly, because I'm not trying to endorse anybody or sort of expose affiliations that I have or do not have. I will say, yeah, and I can say at least from SageMaker because I have a course on it, right? So if any, at least people can just say I'm pushing my course rather than say I'm pushing some vendor. I find the way they built that system, there's a lot of awesome stuff there for you to learn that and for you to learn and for you to like be able to get off the ground really sort of simply and easily. For instance, just one thing that's quite simple, but I think it's great is if you launch an API that's serving a model, you can very easily set it up so that the SageMaker is just capturing all of the inputs and outputs from that model and just storing it to S3 so that later on you can just take a look at those inputs and outputs and understand how your model performed. If there was drift over time, if you get ground truth signal, you can compare that ground truth signal to what your model is outputting. And I think that is that's something that it took the industry a little bit of time to learn, to just once your model is outputting something to save all of the features, all of the inputs and to save the outputs. But once you have those things, you can do so much more. So there are a lot of nice lessons baked into the system that regardless of if you use SageMaker or not, I think there's a lot for you to learn from and apply to your own systems. But if you do wind up using SageMaker, I think it's a nice solution that comes out of the box at this point.
Well, yeah, and then that just begs the question of like, what are some more features, not necessarily in SageMaker, but that you've seen that you're like, woo, this really helps, or this you can iterate on more things because this is now in my toolbox.
Yeah, I would say that's a hard question to answer. Can you give me an example of something?
What you said about the logging, like the inputs and outputs, I think that actually that's a really important one right there. Like I can't stress enough how many problems happen when you're not recording that and you forget what is actually even going on. So I would even say things that like enable like good observability or traceability, maybe those sorts of things, like that feature that it's not like the sexy thing, but it actually is really helpful for, like actually making sure that your process is running smoothly. So I don't know if you can't think of another one, that's fine.
No, I think thanks for the help there. I think that's a good point because actually just this week, I ran into an issue with one of my teams where we have this sort of production system that's generating predictions in real time, and those predictions are used in making decisions later on. And we had a bug that we couldn't diagnose for some period, that we weren't able to diagnose for some period of time because we weren't logging certain parts of the actual stack. And it was only because we were doing some data analysis on previous predictions for another project that we found some anomaly in the data. And then somebody went back and looked at the system and found this bug. And, if we had been logging a particular part of the system and then doing some monitoring on top of what we were logging, we would have been able to tell right away. And what I mean by something as simple as if we had been just monitoring the average output of this classifier over time, we would have seen like regression in this metric, and we would have known right away that there was a problem. But we weren't doing that, and we found ourselves in a situation where we had this silent failure for some, I won't say how long, but a considerable amount of time.
It's funny because I had a similar situation, not a real time situation, but I realized when I looked at the pickled artifact, so like the training artifact, and I saw that every model was doing cross validation had the same memory address. And I'm like, wait, why are they all the same? And I had to look into that because we're doing some prediction analysis, looking at the predictions, and realized that a lot of the predictions are the same.
Mhm.
And we didn't log those predictions, so we were just like trying to like go around figuring out what was going on, and if we had been logging we would have found it earlier. But yeah, I've definitely been in that situation. A little embarrassing, but yeah, this leads me to actually one of the next community questions, if you don't mind. It was
Sure.
about the do's and don'ts of MLOps. I think that's a really big question. So maybe just at a high level, you don't have to go too deep into that, but at a high level, what are some maybe the things that are fresh in your mind, some do's and don'ts of MLOps?
Sure. Yeah, I think that's a pretty broad general question. But I would say, do log everything, do monitor your models, uh, because, and the more do automate as much as possible, I think is an important one, because the more you leave to sort of manual analysis, the more chances you have of missing things. Um, do automate your deployments as much as possible, and tag the models that you're using, the versions of those models that you're using, right? Because at some point in the future, you're going to need to have to go back, and you'll want to be able to refer to the exact model that issued a particular prediction. So that's a pretty important one.
It's a good one.
Yeah, I would say do sort of store your training sets, do store your validation and test sets. I think that's a good list of do's. Some of them might sound obvious to people, but I think the fundamentals are.
No, those are excellent. I would say you could do a lot of good with those things right there. If you're logging things, you can find things a little bit quicker. If you're monitoring, you're keeping track of actually what's going on, right? If you're automating, now the automating one is actually an interesting one because we went through a Google paper, and that was like one of the presuppositions that Google really like, I think is saying is the best practice is automating as much as possible.
Yep.
But we've had some pushback in the community, good pushback about why it doesn't always make sense to automate some of those processes. And I know even at my own company at Benevolent, where we're doing drug discovery, it's a bit tricky to automate some of those things. Like sometimes manual work is actually really important because of the nature of the domain. So
For sure.
even though that's a great point because it does lead to less mistakes, I do think that, yeah, some of these things are really helpful for just helping you move, make progress. Cool.
Yeah, I think on your sort of pushback on automation, I think that's a good point. I will say sort of, and this is anything in life, I try to think through. You want to do the thing manually first to discover pitfalls and to discover issues until you feel confident enough that you can automate it. So, perhaps at first you want to run the system manually, or you want to run the deployment manually because you just aren't aware of all of the issues that can occur. But after you've done that for some amount of time, I think moving it to, automating it is a better thing to do, because it'll just save you development time in the future. And if you're, relatively confident in what you're doing, then automation is a good solution. But sure, at first, you don't want to jump directly to automating.
That's such a good point too. How if you do it manually too, you'll know the process much
Right.
better, and then you're just taking out that potential for human error once
Right.
you start
Exactly.
to automate it. But you have a clear idea of the process. It's not like I'm just automating it and then leaving it into the hands of God to
Yeah.
figure out what's
Yeah, I mean,
happening.
even when you're building a model, right, the first thing you should try to do is look at the samples yourself and try to generate the prediction yourself. Can you do it? If you're not looking at some sort of very difficult to parse feature vector, like an image or something, or even if you're looking at the image but you're not looking at the feature vector itself, can you detect whatever it is you're trying to teach the model to detect? because that'll give you some sort of, it's a manual process, right? Or when you're doing some error analysis, can you look at the features that your model misclassified and sort of figure out some patterns manually before you do some more automated thing like run PCA on a bunch of the errors and sort of categorize them or something?
So we're kind of getting down to the wire on time because David and I fanboyed out a little bit too much before we started recording. But I think we're going to have to do some rapid fire on these last questions. There's a few
All right.
more that I'd love to get through.
Man, and there's some good ones too. Yeah,
I know. If there's one that you feel like, let's take more time on this one, feel free to. And then we may have to convince you to do a session 2 here.
Yeah, I'd be happy to.
So,
oh man, that's awesome.
yeah. So let's look at this one. What is your process in identifying use cases that are suitable for machine learning as a solution? Like, and do you have a methodology around that?
Sure. So it starts with the business goal, right? If there is, I run a small team. Like we don't have like 100 data scientists or ML engineers. We have a pretty sort of skeleton crew. So for me, the problems that we work on I sort of see the ability for a product or solution to have a valuable impact as a product of two factors. One is sort of the potential number of users that the solution can benefit. And then the second part is the ability to actually build a predictive model, right? Because if the model is not very accurate, I say, let's just use accuracy as like a broad term. I don't mean the technical sort of definition of accuracy. The more maybe performant is a better word. The more performant, so it's the product of how performant your model can be times the amount of impact that a performant model can actually have. So because I'm working with a really small team, it's actually more important to work on problems that have the ability to actually impact more users or more parts of the business. Because then even if we build a model that's maybe not that performant, it can still have a positive business impact. Whereas if I work on a problem that has sort of a limited scope of impact, even if we build a really performant model, we may not just have the impacts that we'd like to have as a data science team. So I always start with sort of ranking problems by the amount of impact possible across the business. So that's part number one. And then after that, I look directly to how sort of developed are the data sets that we would like to use to actually build the models. Because if we don't have the data, we can't really build anything.
Ooh.
If we have the data, but it's really like not clean, it's across different databases, we need to sort of standardize and build some normalized data sets. That's going to take up a bunch of time to do. So I'd say like the maybe two primary factors I use, and of course there are others in ranking problems and intaking problems, would be the amount of impact possible, which is sometimes hard to measure, but sometimes you can do, and then also how developed the data sets are that we would have to use to build solutions out.
Damn, that's good.
I think that's great. I just want to highlight we talked about Google putting out great content. There's actually a course that Google has. It's free. It's called Introduction to Machine Learning Problem Framing.
Yeah.
A lot of the stuff that you said there is actually talked about there about how to actually frame an ML problem and whether it's worth actually using ML for that problem. Anyways, But yeah, awesome. All right, next one. Thank you so much. That was really great stuff. And we're gonna share some of these notes for you guys. But the next one is, what part of the ML and production process do you think people underestimate the most? And a second sub question to that is, what are the low hanging fruits that many people don't take advantage of? So what are the parts that people underestimate, and where is there low hanging fruit that people actually miss out on? I guess they're kind of related.
Yeah, I think people underestimate on the ability to generate actual value without needing to build the most performant or complex model possible, right? If you're sort of in academia, or you're trying to win a Kaggle competition, you're really optimizing for the performance of your model. Whereas if you're in industry, the performance of your model, it's the impact that the performance of your model is definitely correlated to the impact that you'll have on the business. But it may not be a direct like linear relationship. So you may not need, 60% accuracy or 70% accuracy might actually be really valuable for your company, depending on what the use case is. And you're better off sort of getting it out the door and getting it into users' hands and measuring, your actual product metric or your business metric, and determining, how well you're doing there, or running a small A/B test or something, then you are going back to the lab and trying to squeeze out another 10% accuracy. Now, of course, that's not in all cases, right? Sometimes you need to be very accurate. Sometimes you need to be very performant. If you're building a self-driving car, for example. But if you're building, a recommender system, you may not have to squeeze all of the juice out of the orange there. So I'd say the ability to generate positive value with sort of a model that may not seem that performant is an underestimated thing in the industry.
Yeah, I think that ties nicely into the last question you just answered too. They go hand in hand, right? Like figure out what the business value is and then get it out the door and then iterate on it and make it, this incredible model that has high accuracy. But first, just try and see if something has impact,
right?
And try to choose the one that is going to give you the most impact rather than this very narrow one. So the way to do it wrong, I guess, is by choosing a very narrow business case and trying to optimize for the model.
Yeah, I would say the way to do it wrong, and I know this because I've done this in the past, is to not understand the business problem as much as possible, not understand the potential value, and then to try to build the most complex thing right away. That is a pretty, I would say,
sounds like a Kaggle competition.
Yeah, I mean, I would say like that's more often, and again, I'm not accusing anybody. I've done this myself, so it's sort of a natural thing for, I think, data scientists and engineers to do, is to want to just jump straight to the solution when most of the value you might be able to get with like an 80% solution.
That's
right,
great.
I think
we have one more.
We get one more, and then
one more, guys.
All right.
This is a good one, and I think it actually captures a lot of the stuff that anyways. But the next one is what you've been in this space in MLM production, right? And it's been evolving over the last few years. Where do you think some of this stuff is headed? And that's a very broad question. I've been asked that before, but I guess I'll leave it up to you how you want to interpret that. Where do you think this industry is headed?
Yeah. I mean, it's clear that there are more and more tools coming out every day. I mean, just 2 years ago, if you just look at the situation 2 years ago, there were way fewer tools to do. Like deployment was challenging 2 years ago or 3 years ago, right? And now there are like, I don't know how tens of companies that have emerged just around deployment, and like maybe 40, 50 companies, I don't know. Now sort of other things are starting to become a little bit more en vogue, like monitoring. There are a couple of companies doing monitoring now, and maybe 6 months, 8 months ago, 9 months ago, around there, like that wasn't even a thing. There weren't that many companies doing this. At least there weren't that many companies publicized doing this. So I think there are going to be, only more and more of these sort of tooling companies that emerge. I'm not really sure whether, I think some companies can get by with just using one platform tool that does everything. Other companies will need to sort of have a best in breed approach where they pick and choose different parts of the stack and outsource that to different services. I think that's only going to continue. So there'll be more and more commodity software available to do some of these common tasks. I don't think that's much of I don't think I'm being Nostradamus in making that sort of prediction. I just think that's how technology gets developed. I would say that there's going to be a lot of sort of these vertical style companies that try to really solve problems within a narrow domain by building, ML powered products. So not tooling companies, right? Tooling companies sort of work across verticals, but I'm talking about like specific companies that solve specific use cases, but use machine learning to solve those use cases. I think we're going to see more and more of those that are going to be enabled by all of these tooling companies that exist. But the real bottleneck there is the domain knowledge. So you're going to need domain experts who understand the data sets and who understand the domain in order to make the modeling possible. But just like AWS made it much cheaper and easier to build, online companies, because you can use cloud software. I think these ML tooling companies are going to make it easier and easier to build ML powered products, because you don't need to sort of bootstrap all the infrastructure. But what's missing then is the serious domain knowledge to actually model out your problems. So if you're a domain expert, I think now is one of the best times possible to build sort of a company powered by, advanced analytics or machine learning, because the tooling is there, whereas previously it wasn't available. But that domain knowledge, if you don't have that, you won't be able to build anything except sort of a generic type solution. So the more domain experts you can get in a room, sort of the better a vertical solution that you can build.
Fascinating, man.
Yeah. Well, dude, you said so many awesome things you talked about. I wish we had more time, Luigi. It was such a pleasure, and maybe we can summarize some of the things. We didn't get to talk a lot more about this, but it was definitely hinted at in a lot of the things you said about starting simple and the importance of iteration, right? It seems like that's a very important thing. It's a good practice. It's something I also recommend. Start simple, then work your way up. But overall, I think we have a lot more that we'd love to talk about in the future, guys. We may have another episode, but
we'll
really
leave it
appreciate
to be continued.
Yeah, we really do appreciate you taking out the time to speak with us, to answer some of our community questions. I had a blast. And yeah, that's all. Demetrius, anything else?
Yeah, well, obviously there's going to be more questions now after people watch this. So throw them in the comments or reach out to us on Slack, put them in the original thread, or just throw them in general, and we'll keep this rolling for part 2.
Awesome. Yeah, thanks so much for having me. If you haven't already, sign up for the newsletter. You can hear me talk much more. I'll talk your ear off about these things.
Yeah, awesome. And the blog. Check out Luigi's blog and the course on SageMaker. If anybody is using SageMaker and you want to get deeper into it, check out his course on that. And I know you're also doing stuff with TWIML.
Yeah, so I gave a talk at TWIML 2 years ago on a Kubernetes-based system that my team built. And we actually partnered on the SageMaker course. So we offered it sort of, we launched it to the TWIML community. It was sort of, it's independent of TWIML, but we worked together to offer the content to the TWIML community. So I was super pumped about that. They have a nice sized community.
Right on. Well, thank you again. And thanks everybody for listening. We will see you all later for the next one.
All right. Take care, guys.